Hello and welcome to the SMD Radio Podcast, where we are always taking a deeper dive into the world of sound and vibration. We as humans are often fascinated by the mere science of sound and vibration, so much so that we often tend to overlook the finer details, like the methods and metrics involved in testing these sounds and vibrations. So today we are talking to solutions engineer Robby Cagle to talk about some of these details. Hello, gentlemen, and welcome to the podcast.
Hello, Craig.
Hi.
Robby, first off, I just want to say that I am fascinated by your fascination with math and numbers, and I have been eagerly awaiting this podcast so we can see what's inside the box. Everyone in the office knows that you are a musician as well as a numbers guy. As a fellow musician, I have to know, did music itself play a part in your interest in sound and vibration, or are they just a convenient synchronicity?
I would say it's probably more of a convenient synchronicity, but my background in music has definitely helped me understand some of the concepts. So in school, I was a pure mathematics major. So I've got a degree in mathematics, but it was pure mathematics for the sake of doing mathematics. So perfect for a weird numbers guy like myself.
I had to get the music question out of the way. I'm sorry.
I could talk about the music portion for the entirety of this podcast, so it's best to hand it over to Bob.
You're right.
Okay, yeah, I'll take it. Okay. So, hey, Robby, I think you gave a little bit of your background with Signalysis, but in 30 seconds or so, can you just give those who are tuning in just a quick, maybe an idea of how long you've been with the company and what your area of expertise is, when you typically get involved in projects and so forth?
Yeah, so I've been with the company about 4.5 years. And, you know, with Signalysis being a small company, we kind of dip our hands everywhere. But I'm mainly kind of the metrics guy around here. I grew up under the tutelage of Kyle Coleman, who is the metric guru around these parts. And so just learning from him and learning from Bob and Neil, the intricacies of modal analysis and structural dynamics, I've learned to apply that to the metrics that we write on systems today.
Yeah, that kind of leads into a presentation I think that you gave, maybe it was 2 years ago at the break colloquium. Does that ring a bell? When was that? That was in the fall of maybe 2018, 2019?
Fall of 2019. Yeah, it was the fall of 2019. It was the SAE break colloquium down in Orlando, Florida. I did have interest in the subject matter itself, but I have to say that Orlando was a selling point to submitting my abstract. But all jokes aside, yeah, 2 years ago, fall 2019, I had the honor and the privilege of presenting a paper that I had written for the colloquium. I had submitted a paper that originally I thought was going to be kind of like an instruction manual for production operators and for quality departments, because, you know, I find that a lot of times when we go into plants, these companies know that they need better quality checks rather than the subjectivity that they're kind of doing on some of their check and quality processes. So what I wanted to do is kind of write a paper that was an introduction to the sound and vibration and all the kind of things that we did, but it kind of turned into more of an exploration of some of the measurement methods that we do, which included a study of different sensors and everything that we use on brake rotor analysis, and then kind of some preliminary studies we were doing on brake pad analysis from a vibration standpoint that has really taken off over the last 2 years since I did write that paper and presented it at the colloquium.
Let's get into that a little bit more, but before we do, I think that paper is available, and maybe Craig can add, unless you know off the top of your head where people would go to request a copy of that. If not, maybe we can have Craig add something when this is available, with a link or something like that we can put in.
Yeah, to get a copy of that, I would just reach out to your local Signalysis sales rep, or just email sales@signalysis.com. And that would probably be the best way.
Okay, and can you provide the title of that paper for anyone who's interested?
The paper is frequency inspection of brake system components.
So let's talk a little bit about some of the common quality issues that brake manufacturers have, suppliers. Can you maybe address that along with some of the results of some of the consequences of these errors, these issues?
Yeah, so, when we're talking about rotors, you talk about bad castings, stuff like that. And that can change your frequency response. And when you talk about a change in frequency response, maybe it's not exactly where you want it. And your brake system, when you apply the brakes, is going to produce unwanted noise. But like I said, kind of where I've really been spending most of my time the last few years is really diving into the brake pad stuff. And so you've got, cracks in the friction material, you've got delaminations, stuff like material buildup. And, some of those things like the material buildup, so like extra friction material along the outside of the brake pad, that can result in, the customer or the end user, whoever that might be, not being able to properly get the brake pad where it's supposed to be within the housing or within the system itself. So obviously that's a bad thing. But delaminations and cracks, those are safety issues. So if you apply the brakes and you apply them just right, you excite the right modes, and you have a little too much vibration in that pad, it could fall apart, and you're going to have a problem stopping your car. So some of those cracks and delaminations are kind of where I've really been spending a lot of my time in finding ways that we can use vibration and sound to characterize that from a mathematical perspective, and be able to apply that to the production line.
Yeah, so it sounds like best case scenario, you might have a few pallets of scrap parts. Worst case scenario, you're going to have some litigation, and could be big trouble for your company.
Yeah, I can't. That scrap parts is definitely best case, but litigation I can't really speak to. But I can't say it's beyond the realm of possibility necessarily.
I was surprised to hear that physical visual inspection is still as prevalent as it is in the industry. What are some of the methods used to detect failures? Would you say that's the primary method that companies are still using?
In terms of at least in the brake pads that we've seen, yeah, it's manually impacting the part. You've got somebody in a noisy production environment trying to listen to a pad, as you maybe ding it or something to listen to it, see if you hear any cracks, and you're looking at the pad, make sure nothing looks weird. So yeah, that's primarily what we've seen is still kind of the method. There are some methods out there, but none that are really conducive to the production environment from what I've seen, at least.
So yeah, it sounds like still a lot of subjectivity is involved in the process.
Yeah, that's definitely true. That's kind of what Signalysis, what we try to do is take the subjective and make it objective. So we understand kind of where a customer might be coming from in terms of, here are the things we're trying to catch, here's our method of catching them, and to see what we can do to take their subjective ratings, whether that be a jury study or some other method of how they're currently testing their product, and create some sort of objective metric for it. And that's where my metric development comes into play.
So can you maybe talk a little bit more about that without giving away any company secrets or any proprietary information? Can you maybe talk about the process for moving from subjectivity to an objective test environment? How you might work with a client to do that? What's involved?
Yeah, so it kind of varies from customer to customer, because sometimes when we're approached, it's our customer's customer is saying, hey, we have this spec sheet. And, it can vary from no objectionable noises to a dB rating to this, that, and the other thing, so varying levels of what they need or want from their customers. Sometimes they've done the analysis themselves and say, hey, we know that these are our fault lines. Can you help us with a system to find those? So if they've kind of done the footwork in terms of some of the modal analysis, we'll look through their specifications and learn from that. Or if we need to do some of that modal analysis on our side, one of the things we kind of start with, we've got engineers, we've got mathematicians, we've got mechanical guys, we've got NASA scientists on staff. So one of the things that we do is kind of, set it down. We're all kind of looking at it from a round table perspective. Pre-COVID, at least we were. I don't know. Am I allowed to say COVID? Is this going up on YouTube?
It's not too soon. You can do it now.
Okay. So anyway, going around the table and kind of saying, well, what are the factors that we have to consider? What are the dynamic properties? When we talk about the brake pad, we have this nice symmetrical linear thing on the back with the back plate of a brake pad. But then you've got this friction material on the front that is so nonlinear, just the natural makeup of it. It's kind of a composite material that's kind of glued and melted together and then glued to the back plate. And so you have this nonlinear structure. Okay, they have this sound issue. How are we going to handle that? How are we going to take their subjective ratings and be able to find that objectively and come up with a repeatable process? The whole time we're working hand in hand with quality departments to make sure that what we're doing is satisfying the quality needs of them, their customers, providing any analysis that's necessary to make sure that they're putting out good and safe products. So once we're kind of past the stage of, okay, here's what we need to do and kind of look for. It's okay, well, how do we simulate free conditions on this brake pad? How do we excite the modes of interest while avoiding node lines? Do we need to impact once, for a brake rotor? That's okay because it's a nice linear structure. You might get some repeated roots issues, but you can usually work through that and come up with a system that gives you a nice response with a single sensor, with a single impact, and you can have a pretty good understanding of what the rotor does and be able to produce a pretty easy system. But like I said, something like the brake pad, you've got all kinds of modes of vibration that are different. Well, not different, but you excite them in different ways based on how you impact it. You've got some small cracks that only really sound themselves when you impact directly in their location. So you kind of have to think of the ways we need to excite that, how, maybe do we need to come up with a way of automating the process that they're doing? Can we do that, straight away? Do we need to come up with a new way? So that's kind of with the brake pad stuff. We kind of had to come up with our own kind of, we have a dinger system, sorry, my voice kind of cracked there, for brake rotors that, like I said, single impact, single sensor, has a nice frequency response. We can check where those peaks are and tell you if it's good or bad, inside or outside of your specs. It's pretty straightforward at this point. It's well established. We don't really see many surprises there. But with the brake pads, we found that if we impacted it at one location and impacted it over here, we got completely different frequency responses, even when we were looking at the same bending mode. And so there are processes out there to handle some of those things. But when we kind of got into the nitty gritty of, okay, these are the quality issues that they are facing, and the methods that are out there aren't really cutting it in terms of what our customers are looking for. So what do we need to do to adapt our dinger system to work for the brake pads. And so that's kind of, like I said, what we've been doing over the last 3 or 4 years. And we've had a lot of success. We've got customers out there who are using our, for lack of a better term, brake pad dinger to use to do brake pad quality inspections. That's kind of a full scale approach rather than a kind of the minimal approach that we've seen others take in the past.
So
sounds to me like even if you have something as caveman as dinger, it sounds like you have this down to a science. Like you sound like you know your stuff.
You know, it's kind of taken over my body and mind over the past couple of years. I think I have a nice level of brake dust just on me at all times. But, you know, and this kind of going back to the music concept, you know, when you're trying to write a song, you know what you want the song to sound like. And so you try this chord, and sometimes it works. And at some point you find the perfect melody, you find the perfect progression, you find the perfect rhythm, and it works, you know, and that's kind of the same thing I like about, you know, the world of mathematics and numbers is there's always a solution. You know, obviously I can ping or I can impact one brake pad and I can impact another one. I know there's a difference between those. There is a solution out there to be able to tell the difference in a way that's not subjective, in a way that, you know, the pads are telling us, hey, I'm good, hey, I'm bad. How do I utilize what they're telling me and go through their data and be able to say, oh, this is the marker, this is the frequency response, this is whatever the dynamic properties that tell us there is a crack here and there is not a crack here. And so it's a nice little kind of, I think it's like a treasure hunt, you know, there's a solution and you just have to find it. And so I'm kind of relentless when it comes to that. And that's the part of the numbers game that I just love so much.
My mind
Sorry, I
is
nerded
blown.
out there for a bit.
I think that was the intention.
Hey, Robbie, can you talk just briefly about the role that software plays in this process?
Yeah, so you know, we kind of have our proprietary software, not kind of, we do have our proprietary software, SigQC. And that's kind of the hub of, again, not kind of, it is the hub of what we do and where we do everything. So we have, you know, our production lines, that's where I've done all my metric writing and everything. So we have all kinds of different mathematical algorithms that we use to develop a full scale algorithm that tells us, you know, a good pad from a bad pad or a good rotor from a bad rotor. So the main thing that we're using is SigQC, especially when it comes to online and on-site production systems. That's more than likely going to be a SigQC quality system. You know, in terms of kind of the development of that process, you know, we'll use some modal analysis softwares like M+P or MeScope, some of those types of things that we'll use in the lab to get a firm understanding of dynamic properties, those bending modes that we're looking for, so we can know exactly what to look for and how to write our algorithms within the SigQC software. But the SigQC software is robust in terms of what it can do. You know, it's got, I don't remember when exactly SigQC came into play, but it's got lots and lots of years under its belt and lots and lots of different applications it's seen. So the tools within there are pretty expansive. I mean, you can do quite a bit with it. So that's kind of our bread and butter.
It sounds kind of customizable if you know what you're doing or have someone that knows what they're doing.
Yeah, it is. And you know, it's, you know, my job is to be able to customize per application. But it's also one of those things where it's accessible. If you have some sort of background and knowledge of, you know, kind of going back to the basics of sound and vibration, the fundamentals really aren't that obscure, especially if you have some sort of a scientific mathematical background. So it's accessible in a sense where you can get in there and get your hands dirty. We have customers who write their own metrics within the SigQC software, and I no skin off my teeth. I love when our customers can take what we've given them as a basic and apply it their own way. I think that's great. Yeah. Ownership of the system. We want you to feel like we're working with you, not that we're the experts and you guys are just, subject to whatever we give you. It's a team mentality with us. We're working
like music.
Exactly. It all comes back.
Are there other non-manual methods in addition to frequency inspection? And why would somebody opt for frequency over those?
In terms of the frequency inspection, customers have come to us and they've done the X-ray methods, they've done the ultrasonic methods, and they don't work. I don't have enough experience to tell you why they do or don't work or how to make them work. That's not my field of expertise. But what I know is that I can separate a good part from a bad part using frequency inspection. Especially, when you think about impacting the good pad versus the bad pad, you can orally hear that. So what we know from that is that the somewhere within the frequency spectrum of where a typical adult human can hear is the solution to the problem. So when we dive into the frequency data or the frequency signature of the brake pad, we're able to look at the difference between those two and understand the difference between those two, and then adapt from there to write some sort of objective metric that looks for those signatures. So when a pad comes down the line, we impact it and we look at that signature, and it either aligns with what we know to be a good pad or it aligns with what we know to be a bad pad. So there's no subjectivity. There's no, well, I think it sounds good, I think it sounds bad. You look at the frequency response and it says, look, my signature says I have something abnormal about me. Mm-hmm. And so the data, it speaks for itself, which makes my job easy. Right. Not easy. I wouldn't say easy.
Easier.
But easier. Yeah.
I know one of the things that's kind of new with the company is visual inspection, especially with brake pads, for example. It's a relatively new technology as far as I've seen. Can you speak to that a little?
Yeah. So in terms of the vision, with the frequency response, you kind of get the dynamic properties, but I kind of alluded to it earlier, some of those material buildup concerns, that's not going to be something that you can catch with the frequency response. That's not going to change the dynamic properties of the pad enough to be able to separate it. So there are other quality methods that you can use to find some of those other defects. So a chip in the brake pad material, if you have some sort of inkjet on there, maybe you're looking for lot stamps that you need to see or read, that material buildup. The vision system, that's what it's designed to check for. So you can utilize that in conjunction with the frequency inspection to come up with a full scale quality inspection for your product, brake pads or otherwise.
So is that typically two different test systems, or is that done concurrently?
It kind of varies. You can kind of combine it all into one, but sometimes one process takes a lot of time, or you find other things that you need to add on one side of it. So sometimes it's best to kind of separate those things. And maybe you can put something upstream to catch some of those defects early on, whether that be a frequency inspection or a vision, depending on your capabilities and what you need to do, and your stream of production. But you can separate those. So, if you've got some process upstream that's causing your vision problems, for example, you can add a system there. And completely eliminate bad parts from ever coming into the impact station in the first place. So you can totally eliminate those concerns upstream, and they never come into whatever station is doing some of the frequency inspection. So you're kind of cutting down on that scrap early on, and then that also helps you do some root cause analysis of where you're really seeing the problems. If you do everything at the end of the line, you just see a lot of scrap. But if you kind of start to do analysis of where in your production these things might be coming from, you can better assess, maybe there's a health problem with one of the machines. Maybe there's better equipment that you could be using. I don't know. That's not necessarily my expertise. I'm just the numbers guy. But I have been doing some of the vision systems lately, and in terms of metric development, it's kind of the same mindset of trying to figure out how to separate good from bad.
Yeah, so you're saying that maybe having these two systems separately kind of might identify some upstream issues and where they might be occurring.
Exactly.
Yeah. So Craig, that's really all I have today. Did you have any more questions for Robby while we have him?
No, guys, I already think we made it, and I think we could have kept going, but I think this is a good stopping point. But we can do this again another time. But we have all walked away a little bit smarter today. I feel a little smarter. But I want to thank you guys for joining me today and sharing your time and your stories, Robby. And thanks to everybody out there watching or listening. And don't forget to subscribe and click that bell so you can stay up to date on all our videos.